Namaskar. So today we are going to integrate cot³x. Till now you must have integrated cot×x. Just giving you a hint that you would have written that as cot×x dx integral. If you look at, you would have written this as cos x divided by sin x. If you take sin x as t, cos x dx becomes dt, and you can proceed. When it comes to integral of cot²x, this can be written as cosecant square minus 1 with the help of identity, and you can again proceed because integral of cosecant square is minus cot x. Here you will get minus of x plus. Now these are the lower powers. When it comes to cot³x, how can we do this? Because we need some derivative of cot×x to be there, which is not present currently. So what we can do is to write this as cot²x times cot×x. Next we are going to derive cosecant square x from here, because this is the famous identity. Now we know that identity 1 plus cot²x equals to cosecant square x. From here you can write cot²x as cosecant square x minus 1, and this cot×x is there. Next we can multiply inside and write this as separate integrals. Minus integral of cot×x dx. So in this, if you take complete thing as I, so your I can be written as I1 if you take this as I1, minus I2 if you take integral of cot×x as I2. So let's solve for I1. I1 is integral cot×x and cosecant square x. Take cot×x as t. Derivative of cot×x is negative of cosecant square x. So from here you can write cosecant square x dx as negative dt. Coming back to I1, so that is, in place of cot×x I write t, in place of cosecant square x dx I write negative of dt. Integral of t dt is t square by 2. Integral of x power n is x power n plus 1 divided by n plus 1. So minus of t square by 2 plus, let's say, c1. Again, what was t? T was cot×x, so cot square x by 2 plus c1. This was all about I1. I2 is nothing but simply integral of cot×x. Either you directly know this integral is log sin x, otherwise you can, as I told in the beginning of the video, you can always write this as cos x by sin x, and thereafter you can take sin x as t. You know derivative of sin x is nothing but cos x. So cos x dx is there in numerator, that becomes dt, and denominator you have t. Dt by t integration is log mod t. T was your sin x plus, let's say, c2. So you have got I1, you have got I2. That was relation was I equals to I1 minus I2. So your I, which was integral of cot power 3x, is I1. What we got as I1? minus cot square x by 2 plus c1 plus I2, which is log sin x plus c2. But always I make this mistake very often. This equation contains minus sign in the middle, and you have not taken minus sign while evaluating I2, so you need to take care of that we do have a minus sign in the middle. Fine. So this minus sign gives you the complete integral I was nothing but integral of cot cube x, and that is nothing but okay, you can do some more adjustment because c1 c2 are both constant, so in the end I can write I was nothing but cot cube x. c1 plus c2 can be merged to a other constant, and if possible you can take negative sign out also. Fine. Plus c, where c is c1 plus c2. Base, if you are thinking, base is always e in turn when you are talking about the calculus part. We don't show the base, but it is obviously e. Okay, so that's it for today. You can watch out more such problem in the playlist Integration 2023. Thanks again.